Good morning. Welcome to the O-Scope Wizard. I'm Gabe, the O-Scope Wizard. You have joined me in the techno lair on this wonderful, lovely Tuesday. It's beautiful outside. Hopefully it is beautiful wherever you are, as you have joined me for about half an hour of super nerdy exploration. You've caught me in the middle of a quest to build a DIY Sonos Style amplifier. We're building it out of a whole bunch of components. We have a Raspberry Pi, we have a TI 3116D2 amplifier board that I bought off of eBay for about $4. I have a digital to analog converter chip, got all kinds of stuff. 24-volt power supply, very exciting. The coup de grace, of course, is the empty wooden box that it all fits in. And we are slowly putting our components together to make it something neat that makes sound for our ear holes. I love sound in my ear holes. Beautiful sound, anyway. In the last episode, I used the time-tested and honored tradition of bumping wires. That is one of the oldest debug techniques. Welcome to the chat. Thank you. Yeah, we made it to a live one. I can't believe it. I'm making a live one. And I see you guys. I see you guys in the chat. I'm going to keep up this time. But as I was saying, in the last episode, I used the time-honored technique, the time-honored debugging technique for engineers everywhere, for people everywhere. Bump the wires. And I used it on these three wires. I was having angry cicada noises in my amplifier. I was prepared to change power supplies, and I had alternative power connections that I was going to try. I had all of these preconceived notions on what was causing the noise. Ultimately, it boiled down to a loose ground connection, which, I mean, come on, seriously? I'm the O-Scope Wizard. I should know a little bit about ground connections. Keep the ground connections tight, firm. That way we can all be on the same level playing field. Now that I have the loose connection solved, although I have it identified, I don't necessarily have it solved because I would need to solder wires. That I will do off camera. Not the greatest solderer in the world. I'm going to see if my Raspberry Pi can automatically turn on and off my amplifier. That means when nothing is happening to the amplifier, I would like it to, power down. Don't use as much current. With that said, I feel like we should say Angry Cicadas more, by the way. And it was suggested that would be a spectacular band name. Feel free, take the band name. I mean, I love it. Maybe the Electric Angry Cicadas. There was a bunch of different band names that came out in the comments on the last video. If you haven't seen it, go check it out. It's the one probably above this in the playlist. You might have to hit the back button. But I'm going to start over here with my amplifier to just explain what I would like to do to make the whole system a little bit more power efficient. I have two things in mind with this. So let's point at the wire that is going to control the power level, the power state of my amplifier. This green wire coming out of the center of my power connection to so this is my amplifier board right here. I'm pointing at it. This green wire controls a very important pin on my amplifier. And to find out a little bit more about that pin, we are going to my favorite spot, the data sheet. Don't forget the data sheet. You knew we were going to come back to the data sheet eventually. And on this chip, there is a pin called standby right here, SDZ, or shutdown, standby, shutdown. On the board, it's labeled standby. In the description here, it's labeled shutdown logic input for audio amplifier. So the outputs will go to high Z when this pin is pulled low, and when this pin is sent high, it will enable the outputs. So right now, if we go over to my setup, the light on the amplifier is on because this signal is pulled high, so I have it tied to a VDD signal, so a 3-volt signal. If I switch this input to a low signal, so ground, the light goes off. See, so it's off, it's on, off, on, off, on, off, on, off, on. What is happening is when it is off, the amplifier is actually going into a low power state. So if I go over here, I have, I have a really wild, there we go. I don't want that ring of light. This is the amplifier in an off state. So I have my multimeter hooked up to the current path of my amplifier board, and I am measuring the current of my amplifier while nothing's happening. So I'm not sending sound out of the amplifier, but every electrical circuit, when it is energized, burns current. Amplifiers are really bad about burning current when nothing's happening because they're ready, man. They're ready to send sound into your ear holes. What that means is even though nothing's happening, this is like poised and it could turn on in an instant. But a lot of times you don't want it to turn on in an instant. And so at the low power state, you can see I'm actually burning less than a milliamp of current. So right here on my amplifier, or my multimeter, you can see it's less than a milliamp. It's a couple of hundred microamps. Is that right? Milli, micro? That is right. As you go down in tens. Microamps. Now, if I energize my amplifier, so I'll energize it, and you can see, boom, hundreds of milliamps, which isn't that bad. But two things are happening while it is energized. When the amplifier is energized, it is burning more current to do nothing. So why would you waste power? Come on, guys. We're trying to be better. Let's not waste power. But also, when it is energized, random noise can come out of those speakers. So angry cicadas, any sort of electrical interference that's going to pass through the speaker wires or really through the audio input of that amplifier board would be amplified and then sent out. And you would have random noise that would get from the speakers into your ear holes. That is no bueno. No bueno. So we are going to, when not in use, disable this amplifier. So now we're back to disabled, burning very little current, saving power, protecting our ear holes. All of this is good. Now what I would like to do is ultimately use my Raspberry Pis. Whoa, well that was mighty, that was super close up, super close up. I would like to use my Raspberry Pi's massive amount of GPIO pins. I'm using a couple of them already to transmit that digital data, but I would also like to use one of the GPIO pins to control this shutdown or standby pin on my amplifier. So I have identified pin 12 as a likely culprit. So GPIO 12, I chose that using random guesswork. I don't know, just a random choice. I chose GPIO 12. It's wide open, so why not use it? Right now, I'm just connecting this this pin from VDD and ground, but I want to automate that. And it doesn't actually require any current to activate this. You just need to set this to a voltage level. So the GPIO pins on the Raspberry Pi are great. They're great at setting voltage levels. The chat says I use an educated guess to choose GPIO 12. Yeah, we'll say that. Educated guess. If I go back over to my web browser, I did some Googling. So I went over to the Moode audio forums to see if anybody else was asking, how do I control an amplifier? So this person wants to control a whole amplifier, like a plug-in amplifier, and they're going to use a relay. I don't have to use a relay because I already have some digital pins on the amplifier board that I can use. Now, let me get back on track. So I'm in this forum for Moode Audio, and this guy is wanting to control the 120 volt or 220 volt through a relay. I just want to control this standby pin using digital logic. So look, he's using GPIO 12. I think that might be where I got the idea. Don't tell anybody. But I didn't need to go to such lengths as this person. They asked how to do it in Python, using a cron job. But then later on, people were discussing it, and this guy made some really cool modifications. So he updated it to Python 3, made it a service, and I followed that link, and it got me here, and he already has the source code written. So it's very simple. You make a couple of files, relay toggle.py, and then relay toggle.service on your Raspberry Pi, and this should disable the amplifier if no sound is being sent to the amplifier. So if the Raspberry Pi or Moode audio is in a state of playing any sort of sound, any sort of audio, it will enable the amplifier. And then every 5 seconds, it will check to see if it is still playing audio. And then if it is not playing audio, it will disable the audio amplifier. So, yeah, let's see if we can get this up and running. I also have my oscilloscope plugged in to GPIO 12 so that I can check its state. If I go over to the oscilloscope, we'll be able to use channel 1. Right now it's set up from something previous, but look, boom, channel 1. So we are monitoring GPIO 12 right now. Let's get this thing scaled right so it'll at least fit on the screen when we can see it. Move it down a little bit, scooch down. It's 3, so the GPIO outputs on the Raspberry Pi are 3.3 volt logic, so I would expect this to switch from 0, where it is now, up to 3.3 volts or thereabouts. So I'll set a trigger somewhere in the middle, 1.5 volts. So you can see I've set my trigger level. So when this output goes high, it should trigger. So I'm also going to set it up to only actually trigger if it sees a hardware trigger. Now, let's go back to my webpage here, where we're going to do a little coding. I didn't know how this was going to go on camera, but first of all, we need to connect to our Raspberry Pi. So I'm going to connect to, what is it, SSH Pi at mood.local. And then I think the password is Mood Audio. Let's hope. Yeah, okay. So the password is Mood Audio. We're connected. Hopefully everybody can see my screen. Let me know if you can or cannot see my screen. And if you cannot, then I will make some adjustments. But if you can, then yay! Okay, I don't think that, so let's check. So it wants to put everything in the home directory. I don't have anything in the home directory yet. But the steps are create relay toggle.py in the home directory. One of the cool things about the Raspberry Pi is it has a Python runtime already installed by default, including on Moode Audio, so you can run these Python scripts right away, which is kind of cool. Everybody can see it. Yay! Awesome. So let's connect up. So sudo nano. This is my text editor of choice. This can be a real debate for people, and I need to call it relay. I'm going to do everything relay toggle.py. I'm just copying and pasting things to minimize the chance that I have some terrible problem. So here is relay toggle.py. Now I'm just going to copy and paste some stuff. So let's copy all of this. Boop, boop, boop. Copy. And back to my text editor, paste. Boop, boop, boop. Okay, there we go. I believe, yep. Okay, everything's pasted in. Does it have I just want to make sure it's got it. Okay, yeah, it's got the stuff that did not. There we go. We got the. So right here, let's go over the code really quickly. So it's using GPIO, RPI GPIO to read and write to the GPIO. So this is a service that you can run in Python. We import the OS and we import time because we need to check the state of our audio player every 5 seconds. This says it is using relay pin 2, so GPIO pin. That might need to be changed to 12 to work with mine. We'll find out. Now it sets the GPIO to output, so we can output something to our relay pin. Now it goes and checks to see if our audio player is running, so it greps a statement here, just a string, and it looks for the word running. So when running is present, then let's turn the outputs on. So while true is running, true, let's activate it. Otherwise, it's going to turn it off. So when it is not running, if no audio is happening, it's going to deactivate. And there is really handy logic in here. So the algorithm is already built, and it checks every default delay. So every 5 seconds it checks time.sleep default delay. So the last time we checked, let's wait 5 seconds and then we'll check again. This is so that you don't have a process running away in the background just eating up CPU cycles. 5 seconds is really slow, so I was wondering about that. Oh man, okay. Can I make the font larger? Oh man. Oh goodness, can I make the font larger? I don't know how to do that, guys. Can I do that in Nano from the command line? Ooh, you're gonna make me wish that I had used the proper graphical user interface to run my text editing. If you know how to make the font larger in Nano, or if you have an alternative text editor, it says in the terminal, can I make the font larger in the terminal? Oh, there we go. Let's see if I can make the font larger. Terminal. Certainly one could make the font larger in the terminal. I am going over here. Okay, here we go. Yeah, let's see if we can change this to something larger than 11. Let's see if 14 will do it. Does that make it bigger? 18, does that make it bigger? Okay, so I tried changing it to 18. I'm using the basic default terminal. Do I need to reconnect though? Let's save this. I might need to reconnect, which would be fine. So let's escape this Nano terminal. Control X. Yes, we would like to save this as relay toggle.py. Let's exit. Is it exit? Yeah, it's exit. So let's close that terminal window and we'll open up a new terminal window. Holy moly! Yeah, yeah. We may have we've overcompensated, but I think we'll be fine. Let's connect back up to Moode local because we've got one more file to make, guys. Here we are. We're back in. We're back in. Now, I need to make a service, which I'm not exactly, I mean, I am no Linux expert, but a service is a program that'll run in the background over and over again. And it says I need to put relay toggle.service in library systemd system relay toggle.service. So let's at least start in the proper directory. So we're going to, let's make this a little bit smaller so I can see where I'm going. So I need to go to lib slash system d slash system. Oh, you know what? I forgot my first slash, so that's why it's complaining. So slash lib. There we go. Now it'll start doing autocomplete. Thank you. Slash. Okay, that's where we need to be. So let's ls, and I don't believe that I have a relay toggle.service already. I did do this before just to make sure it would work. But I think I deleted everything just to make sure we were, you know, I was going through the same pain that you would go through. I like you to see the pain of engineering. I don't know, it's like this weird, I should probably have already done this like a proper professor. A proper professor would have already done it and just been like, the rest is left to the student. But I always hated that in school. I wanted to see like all the little steps. So let's sudo nano relay toggle dot service. Am I spelling that right? Yes. The reason I'm using sudo is because this directory right here requires administrative privileges. So I'm using sudo in here to make this file. And I want to basically just copy this source code into this nano, into this text editor. So let's copy it, boom, copied. Okay, it is telling me that I am making a relay toggle daemon service. Do you say daemon or demon? This is a debate. I'm reading a book right now that has this word in it. Is His Dark Devices? Is that what it is? Philip Pullman? Anyway, this word, daemon. I would have said daemon, but when I looked it up, I think the pronunciation is actually demon. When I got the Audible book and just heard what the reader read it as, and the reader said demon, but then I was like, is it daemon or demon? Anyway, whole big thing. I've already said daemon when it's spelled this way. But ultimately, this service is looking in my home directory for relaytoggle.py, and it is going to crank it up and run it as a service. So let's save this. So we'll save this, yes. Now, I have my two files saved. If I look for it, it should be in here. If I can spell relay toggle.service. So solid, it's all working. Now, I need to continue following the directions. So I need to enable my service and then start my service. So let's do that. This chat says Damon. Damon. You must be from the deep south. Deep south, sir. If I say Damon, I don't know where the D came from. Hey, to each his own. Let me get the scope out of the way for a second. Let's follow directions. So enable the service. So sudo system control enable relay toggle. Boom. I love autocomplete. If you start typing something and you hit tab in the terminal, it'll autocomplete for you. So we will enable that. It creates a symbolic link. It is enabled. Now we need to start our service. So relay toggle start. Now our service should be started. What this means is when it's going, the pin should go high, and when no sound is coming out, the pin should be pulled low. Ideally, we'll see if it actually works. GPIO or 2. I'm wondering if I needed to change this relay pin, GPIO pin, to 12. Let us find out. That is an easy switch. to make. What do I need to see now? I need to see my scope here. So let's check out the scope. And as it's going, I want to see this pin go high when music is sent to my Raspberry Pi. So I have my phone here to send music to my Raspberry Pi. That should be simple. I should be able to select my Moode AirPlay. So I select Moode AirPlay from my list of audio devices and hit play. And does the signal go high? No. No. So do I need to change this to GPIO 12? Let's go back to my terminal. So I'll show my desktop again. Let's stop my service real quickly. Relay toggle. Stop. I don't know if you actually have to start and stop the service every time. All right. Before you edit it, I'm just going to, just in case. So now let's go over to our home directory. So cd/, well, that wasn't right. Home Pi. There we go. Here we go. Back into the relay toggle.py. So let's edit that again. I don't think I need to sudo this thing. Let's change this to relay pin 12 and save it. So we will save it. Yes. Oh, we do need to sudo it. Oh, no. Probably because I did it at the beginning. Oh. What a bummer. That's okay. We save it. And I wonder if it's asking me to be administrator because I created it as administrator. I wonder if I need to delete this, make it not administrator. We'll see. That could also be a problem because when you're running a service and if the service can't enable a script because it requires a different level of authority on the computer, it won't run that script. Oh, I might have created a little bit of a problem for myself, but let's see if I can start this service again. So sudo service, relay toggle. Oh my goodness, do I have to go back to that directory to start it? Let's go back to the directory just to make sure. System. Okay, sudo service, relay toggle. Start. Will it start it? I believe it will. There was some question in the chat whether the sudo was absolutely necessary. That is a valid question. I do not know. I do not know. Let's see if I go back over to my scope, though. That is a weird screen. Here we go. Now we're seeing the scope. If I hit play, it's in the server. Oh, there we go. Look, boom. We toggled it. So we're playing, and it is enabling our output, which is awesome. This is awesome. This is great. It does two things for us. It allows us to automatically disable the amplifier when no sound is going, and automatically enable the amplifier when I want sound to go. So it is stayed high. I'm going to set this trigger to be rising or falling edge. And now I'm going to pause the sound. So if I pause it, it should go low after 5 seconds. Let's see. Went high. Low? Low? It's going to go? You going to go low? Yes, it did. That's a long 5 seconds. I wonder if I wonder how accurate that time is. When you use the clock inside of a Windows computer, sometimes your 5 seconds can really crank up quite a bit. A little more than 5 seconds, one would argue. I think 500 millivolts a division is probably good, but I'm clipping down here at the bottom and I just don't like it. If I hit play, 1, 2, oh yeah, so there was a 2-second delay between me hitting play. It says, am I adding external inputs? I am adding, so right now I am adding an output to the amplifier. So this signal that I'm observing on the oscilloscope will be connected. In fact, I can connect it to the amplifier standby. So let's go back over to my setup so you guys can see it. So I'm going to, this wire which goes to my I've got my fingers all in the way. This wire that goes to my standby on my amplifier is connected to this yellow wire, which will ultimately be connected to GPIO 12, which I'm monitoring with my oscilloscope. I have kind of a rat's nest of wires. I'm going to get this clean. Oh, and there you go. See, it's enabled. Sound is going. It's a little loud, little loud. Let's pause it. Boom. And now, how long will it take before this disables? So I've paused it. It can take up to 5 seconds, I guess. Gonna wait awkwardly while it pauses, I think. Allegedly, this is gonna go low. It did before. There it goes low. So you can see the light is out on my amplifier, and the GPIO is controlling my amplifier. I think we should declare success. It has been half an hour. I've been droning on for a little bit longer than half an hour. I am super excited. I'm super excited. Now, when sound is not playing through my audio amplifier, I will disable that section of the circuitry, which will clear out sound from the speakers and draw less current. There was a question. The encoder button on the front of the amplifier. What am I going to do with that? That is a great question. This episode, it's a huge success, guys. Huge success. Yay! It worked. I'm always surprised when is it wrong to be surprised when your circuit works? It feels like the first time when your circuit actually works, when your program actually works. It shouldn't be surprising, but it is always surprising to me, even after, how long have I been doing this? 20 years? I'm 40 years old. About 20 years, including debugging in college. Every time my circuit works, the first time, I'm surprised. I should not be. But I am. I feel like that's part of the magic of it. But the question was, this knob, this incredible knob, on the front of my amplifier, which is also a push button. I'm going to use that push button to do something neat. I'm going to use that push button to hopefully control multiple external inputs. So the Raspberry Pi itself will be one of the audio inputs, but I would like the option to have a second external input, so just a 3.5 jack into the amplifier, and that is this little board right here. If we can get it zoomed, or can we get it focused? There we go. This little board right here will allow me to switch between two different inputs, two different 3.5 millimeter inputs, and it uses this mechanical push button. But this mechanical push button, you can't control that with the GPIO pin. So I also have this relay board, which I can control with the GPIO pin. And I'm going to route some of the wires from this switch, from this little audio switch, through this GPIO, or this relay, and I'm going to control this relay with a pin from the Raspberry Pi that will be triggered, hopefully, this is a big project, by that push button on my audio amp, or on my audio amp. That's the overarching goal. That is a future episode. It should be really, really cool if it can actually work. I'll be amazed. Again, chat says they also like to celebrate the little things. When you have a good thing, celebrate it. Take a little time. Feel good about yourself. We made it work though. Thank you so much for the help. Thank you for the tips on how to make my font bigger. Thank you for sticking with me live. Thanks for asking the questions. I really appreciate it. It gives me somebody to talk to, which is really important right now to stay connected with your fellow human being. I don't know all the nerds in the world, but I'd love to meet them. So please share this with a nerd in your life, and hopefully I can meet more and more nerds out there. I'll see you guys on Baby Friday, where we will begin to try to use our push button to switch audio inputs. I got a lot of stuff to do. I got a lot of soldering. I got a lot of rat's nest of wires to correct before then, but I think I can get it done. And hopefully our amplifier, our DIY Sonos Style amplifier, will only get more splendiferous in the future. I'm gonna hang out in the chat. I'll talk to you guys later. Take it easy. Bye.